Hello, geometry students. What we're going to do today is we're going to look a little more at volume, but we're going to look at volume of a couple of other shapes. We're going to look at volume of pyramids and cones. Now, hopefully you watched that little short video that showed you how if you take three pyramids with the same base area and same height as a prism, it takes exactly three of them if you fill them up and dump them out to fill up that prism. Now, the volume of a prism was area of base times height. And that was it. So capital B times H, area of the base times the height. Now, since a pyramid, it took three of them to fill it up, well, that means a pyramid would be exactly 1/3 of the volume of that same prism. And so since a prism is area of the base times the height, a pyramid then is 1/3 of that volume, so 1/3 of the area of the base times the height. So there's our big formula we're going to be using to find volume of a pyramid. So I have a pyramid here, and in this pyramid we've got a square base, and so we want to do 1/3 times the area of the base times the height. So in this one, our volume would look something like this. To find the area of the base, now remember this is different depending on what the shape is, but our base here is a square, so 14 times 14 is 196, so length times width, or the side length squared. So the area of the base is 196. And so the volume then would be 1/3 times 196 times the height, which is 12. All right, so basically in the end then, what we want to do is we want to do 196 times 12 times a third, or an easy way to do this, if you're typing this in a calculator, I just do 196 times 12 and then get that answer divided by 3. Because multiplying by 1/3 is the same thing as dividing by 3. Or if you want an even easier way, 1/3 of 12 is 4, so you could just do 196 times 4. There's a lot of options for how to do that from there. But however you decide to type that in or multiply that all out, you're going to end up getting the volume on this one is 784. Now remember, we're still doing volume, so we're still talking how many cubic units does it take to fill this up. So how many 1 inch by 1 inch by 1 inch cubes would it take to fill in this entire shape? And so this would be 784 cubic inches is what it would take to fill up that pyramid. So that's how we find the volume of a pyramid. Now I want to talk a little bit about how to find the volume of a cone as well. This is extremely similar to how we do a pyramid. The only difference is, well, if we look here, there's actually not a difference in the formula. The only thing we can do is go a little farther and make it more specific. Because if you're talking about a pyramid, the base can be a square, but the base could also be a rectangle, or it could be a triangle, or it could be a hexagon. There's a lot of different shapes, and so you got to do a different thing to find the area. For a cone, the base of every cone is a circle. That's part of the definition of cone. And so if that's the case, it's still the exact same equation, 1/3 times the area of the base times the height. The only difference is the base is a circle, and the way we find the area of a circle is pi times radius squared. So we could make this formula a little bit more specific to a cone and call it volume is 1/3 times pi times radius squared times height. Because this part right here is the area of the base, because the base is a circle, and the area of a circle is pi r squared. So let's see if we can put this to use now. Now I threw a little curveball in on this one. So we want to find the volume of this cone. So here's what we've got going on. Our radius is 5. All right, 13, we have to think about that. Is that our height? Well, 13 is actually what we called the slant height, or we used an L for that. That's not the height we want. That is slant height. When we're dealing with volume, do you notice it's H, not L? We don't want slant height, we want regular height. Which means what we actually want in this is this distance that goes from that center of the circle to the apex of the cone right there. And so we've got 5 for this side, we've got 13 for this side, and we're going to do, looking at this from a side view, we can see this is a right triangle. But 13 is the hypotenuse. So we're going to do a squared plus b squared equals c squared. However, a and b are 5 and unknown, and then c is our 13. And so we're going to do something like this when we set this up. We're going to say 5 squared plus b squared, or if you really wanted to, you could just call it h squared, because h is what we're finding here, equals hypotenuse squared. Hypotenuse is 13. And so doing a little math here, that's 25 plus b squared equals 169 when I square both of those. If I move the 25 to the other side, I get b squared is 144. And so to undo the fact that b is squared right now, we've got to do the square root. So I'm going to take the square root of both sides, and that gives me that b, or in other words, the height here, is 12. And so this distance right here is 12 inches. Everything's in inches on this one. So now I've got everything I need, because I want to do this, or I could do that, but just replace area of the base with pi r squared. So r is 5. The height, not the slant height, the height is 12. And so to find the volume of this thing, it's going to be something like this. 1/3 times pi times radius squared, so that's 5 squared, times the height, so times 12. All right, and there's a couple options for how we could do this. I'm going to start by putting this in terms of pi and leaving it that way. And you could leave your answer like that if you want. That's real common on like an ACT or some standardized test like that. Or you can get your answer as a decimal. It just depends on what you're doing with the information and what the question is asking you to do if it's a question on a standardized test. So I'm going to do this. I'm going to kind of try to do something a little clever here. 1/3 of 12 is just 4. And so that gives me 4 times pi times 5 squared is 25. And so I just did 1/3 times 12 to get the 4. I squared the 5 to get 25. So 25 times 4, that makes this 100 pi for the volume. And that would be in cubic inches. Because our units are inches, we're doing volume, so cubic inches. So our volume is 100 pi. And if you're asked to leave your answer in terms of pi, that's our answer. Now, if you're asked to give the answer rounded to a certain number of decimal places, I'm going to do 2 decimal places. Just doing 100 times, I use the pi button to be a little more accurate. If you just did 3.14, this would come out to exactly 314. But using the pi button gives us a couple more digits. Rounding it to the nearest hundredth, we get 314.16 cubic inches for the volume. And so either one of these 2 answers would be a correct answer for that volume. And so if you were doing something like for practical use where you actually want to know like how much liquid this thing holds, you'd probably want it like that, because you can't really say like 100 pi in terms of ounces and things like that. It doesn't make sense, and so we probably want to change it to a decimal. So there's how we find the volume of a cone. So in both of these, remember, we're after the height, the regular height, not the slant height like we did with surface area. And we want to figure out volume, which is, in both cases, 1/3 times the area of the base times the height. So big change from prisms and cylinders is we stuck a 1/3 in front of it. So a simple way to remember all these volume formulas is this. If you have a shape that's the same size on both ends, you do the area of the base times the height. If you have a shape that has an apex or comes to a point on one end, then you stick a 1/3 in front of that. And that actually takes care of all 4 of those shapes' volume formulas. All right, that sounds great.